Hello, this is question 6 from the Cambridge International Education exam from 2019 winter set, and it's paper 2-2. You can find a link to an image of this question in the description below, and I recommend that you try the question first before doing the solution. Part A of the question can be seen here. The integral of 3 divided by 2x they tell us the answer is equal to the natural log of 27. This is when it is calculated between 2 and 18. They often do this. They tell us what the answer is, which gives us a nice little hint. One recommendation I have for you in an exam is to try and ignore the easy part. Just try and work with this part, but use this as a guide for where you're going to go, especially later on in the question. Oh, am I anywhere near this? Oh, how do I make it look like this? But really, you don't need this to answer the question. This is the answer they've given you. You could and maybe should be able to get the answer to this without this. Although you might end up leaving your answer a little different. And I think we'll see that. Okay, so how do we go ahead and integrate this? Let's just try it now. The integral is, we can take constants out. 3 over 2 has nothing to do with this integral, so we can leave it outside here. So it's really just the integral of 1 over x. And that's a special case. It doesn't work with our usual formula, but we do know what the answer is. It is 3 over 2 is still here. It is the natural log of x. And this is evaluated at 18 to 2. 18 to 2. I won't always write those numbers in, maybe at the first bit and the last bit. I'm a bit lazy. Maybe don't be lazy in your exam. I don't recommend it. Okay, so let's go ahead and evaluate it. This is equal to 3 over 2 natural log 18. We put this number in. And then we take away, we put this number in. 3 over 2 natural log 2. Doesn't quite look like this yet. This is where we start hopefully getting ideas. A couple of things we can do is we could take 3 over 2 out. 3 over 2 natural log 18. I should have probably done that already. Minus natural log 2. Okay. Now, let's think of our rules about natural logs, about all logs. When a log take away another log, once they have the same base, this is a log to the base e, log to the base e, they're both the natural log. When they take away like this, it's the same as 3 over 2, let's put in some more equals, always forgetting them, which is equal to 3 over 2 natural log of 18 divided by 2. We can combine them like that. This is one of our basic log rules. Let's take this up here. This is now becomes 3 over 2 natural log 9. Still not quite like this, because you'd be tempted to leave your answer like this if they didn't tell us. So this is still part of the question. Well, one more of our basic rules about logs is when you have a number multiplying a log, it is the same as a power of the number inside the log. Like this, okay? Still not quite the same. You have two choices what to do here. 9 to the power of 3, then that number to the power of 1/2, or the square root of that number. That's too big for me to do in my head. Well, no, you know what? 81 and then I guess 729, I think. Still a little too high for my head, so I'm going to go with the easier option. 9 to the power of 1/2 first, or the square root of 9, which is 3, and still to the power of 3. That I can do, and this one I can do then. 3 to the power of 3 is 27, which is fine there. If you had gone the other way, you still would have got this answer. That is part A. That's how you can get from this to this. If you have any questions, let me know in the comments, or I'll rub this out and I'll start part B. Here is part B. They ask us to find simply the exact value for this formula and show all necessary working. Okay, so sometimes you might actually be given a formula for how to integrate sine squared, but I'm going to go ahead and assume you aren't in this case, because that's a bit easy. What's something that you will be given is some trigonomic identities, and this will be given on a page in the back of your exam, or maybe in a booklet separately. And one that's very useful here would be the fact that sine squared, let's say a, we'll just use different numbers than that. Sine squared A is the same as, I have to double check myself here, is the same as a half multiplied by 1 minus cosine 2A. So this would be given to you in the exam. And if we go ahead and use this, that's how I'm going to solve this question. Because this is a bit difficult to do at the moment, but if I go ahead and use this identity, I'll see if we can solve this. So let's try that. We'll write this out again. I'll leave these numbers off until the end, or until I end up changing something, which I may do. The 4 can be left outside. Sine squared, instead of sine squared now, I'm going to write a half 1 minus cosine. And then what number's in here is 3 divided by 2x. But I need 2 times that, because a becomes this guy. 2 times a becomes 2 times this. The 2's cancel. We get 3x. Hopefully you follow where I got this 3x from this. It's 2 times this guy. And the x never changed. No, I didn't have to substitute out x in any way. So okay, let's try and solve this question. This question I think is much easier than this question. Let's see, with a half can still come out. We can get 2 out here. We have 1 minus cosine 3x dx, much more manageable. Let's spread this out a bit more. 2 times 1 dx, and then minus 2 times cosine 3x dx. These questions done separately will be much easier. We're nearly there. The integral of 1 is just x, so that's 2x. Minus 2 times the integral of cosine is just sine. And when we have a 3x here, when we're integrating this number, this constant here, just ends up dividing. So we have a sine 3x. And that's it, that's the integral. We still would have to evaluate with whatever numbers they give us. That would be pi over 6 and 0. But that's a simple enough matter of just filling these in. Let's say I is equal. We'll just call this whole thing I, just to make it a little clearer what I'm writing. So I bet I'm writing this line again. This line here is I still. Let's fill these numbers in. Pi over 6, so that's 2 times pi over 6, minus 2 over 3 sine 3 times pi over 6. Then minus, let's see, minus, we put a 0 in, that's 0, so minus 0. If we put a 0 in here, sine of 0 again is 0, so that's just minus, I guess it's minus minus, so plus 0. Not that it matters. These two guys can be fully ignored. They are 0. Not always. Usually you get 4 terms here. It just happens 2 of them are 0. Right, can I clean this up any more? Let's see. This becomes pi over 3. This becomes minus 2 over 3 sine pi over 2. So what is sine pi over 2? Sine 90 degrees. I always try and just draw a little picture of myself, but I certainly recommend using a calculator as well. There is pi, there is 2 pi, here is pi over 2. That answer is 1. This guy is 1. This is equal to pi over 3 minus 2 over 3. That's our exact answer. Yeah, the exact value of this is what they ask us to get. And that's it. If you have any questions how I did that, I certainly, if you're confused about this part, that'll be a separate section. We need to maybe prove this, but you are given it in the exam. What else could you be confused about? Yeah, let me know. You let me know what you're confused by. I'll try and help you out as much as I can. Thanks for watching and have a good day.